In this lesson, we're going to be reviewing how we add, subtract, multiply, and divide fractions. First, let's just remember what the denominator and the numerator mean in a fraction. So I've got 3 over 5 there, and the 3 is the numerator, the 5 is the denominator, because the denominator tells me how many pieces make up a whole, so 5 sections in total, and the numerator tells me how many are actually shaded in, which is 3. We will also be wanting to be able to find the lowest common multiple of two numbers. So if I want the lowest common multiple of 4 and 6, the multiples of 4, remember that's counting up through the times tables, so 4, 8, 12, 16, 20, and I could keep going if I wanted to, but there's not any need at the moment. And the multiples of 6, 6, 12, 18, again I could keep going, but I've already seen the lowest one that's on both lists, 12. If there wasn't a number on both lists yet, I'd have to keep going, but I've got 12 there. Now, when we're going to be using this lowest common multiple idea here, we're not going to be showing all the working like that. We're just going to be asking ourselves, what is the lowest number that 4 and 6 both go into? So 4 goes into 12, 6 goes into 12. There's no number that is lower than 12 that both 4 and 6 go into without remainder. So that's the lowest common multiple. Another thing we need to be able to find is the highest common factor. And so if I want the highest common factor of 12 and 18, then I would start by listing the factors of 12. Remember, that's all the numbers that go into 12 without remainder. And then I would list the factors of 18, and I would see what is the highest one that is on both lists. Now, there's quite a few on both lists here. 1, 2, 3, and 6 are all on both lists, but 6 is the highest, and so that is our highest common factor. And once again, we wouldn't really bother showing all this working if we had to work out the highest common factor as part of another question like we'll be doing. We just ask ourselves, what is the highest number that goes into 12 and 18, and whatever that is, that's the highest common factor. So 6 goes into 12 and also into 18, and there's no number higher than that, so that's the highest common factor. Now, we'll also want to be able to convert between mixed numbers and improper fractions. So this is a mixed number, it's got two wholes, and the fraction part is 3 over 5. And if I was to draw that, it would look like this. There's my two whole things there, and here's my 3 out of 5. Now, to convert it to an improper fraction, all I want to do is I want to get rid of the whole part here, and I just want to say how many pieces are there in total. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pieces, and 5 pieces still make up a whole, so it would be 13 over 5. Now, without drawing it, I can still work it out pretty easily, because I know that each of these holes here has got 5 pieces. As we can see there, there's each of those two holes, 5 pieces in. That was 10 in total, and then we just added the 3. So really, to get this number up here, we're just multiplying the mixed number, the whole number, by the denominator. That tells us how many pieces are there in the whole numbers, and then we're adding the 3 extra pieces we've got. So 2 times 5 plus 3. Now, we could also go the reverse. We could start off with our improper fraction and go back to our mixed number. And so we want to know how many wholes there are in total if there was 13 pieces and every 5 pieces makes a whole. And so all I need to do there is divide the 5 into the 13, and it'll tell me that there's 2 of them, and then I work out the remainder. And so we know the answer is 2 3/5 because it's the same thing as over here, and it's the same as my drawing down there. But that's the reason. It's because you do 13 divided by 5, top minus bottom, and then the answer, it goes out the front because that's how many holes there are, and the remainder goes on top because that's the fraction piece you've got left over. Okay, let's begin with adding fractions, and I'm going to add 2/5 to 1/5. So here's 2/5 and there's 1/5. Notice this one's got 2 pieces shaded in, this one's got 1 piece, so when I add them together it makes sense that there would be 3 pieces to be shaded in. And the reason that works so nicely is that these pieces here are the same size as those ones there. So this piece is the same size as that one. And so I end up with 3/5. Now, if I'm doing 1/3 plus a half, that's not quite so simple, because this piece here, it's not the same size there. You could say that, well, it's just because this one's drawn lengthways, but if you worked out the area of that, you'd find that it's actually less than the area of this. So they're not the same size. So what we're going to need to do is we're going to need to make it so the pieces are all the same size. And I'm going to do that by splitting this one in half here and splitting this one into thirds going down that way. Now notice that this piece is now the same size as that one. This one's the same size as that one. They're all the same size as each other. And so now I've got this new fraction here. This is actually 2/6, which has exactly the same value as 1/3, but the key thing is that its pieces are the same size as that one, so now the adding becomes easy. So we've got, that's 2/6. This one here, that's 3/6. So I've got two pieces there. I've got three here. They're all the same size because they're all sixths, which means that in the end, I've just got 5/6. So the key thing is when we add and subtract, works the same way with subtracting, we need to get that denominator the same first. Moving on to multiplying fractions now, we're going to find 3/4 times 5/6. Now remember, in maths, times when we're dealing with fractions is like saying of. So really we're working out 3/4 of 5/6. So if we get our 5/6 there, we're looking for 3/4 of it, which means that we're going to split every single one of these bars into 3/4. So I've split them all into the quarters and I've shaded in 3 of them. Notice all of these ones here, they've been shaded twice. They're telling me what my answer is. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of however many boxes there are in total, which is 24. And so that means 3/4 times 5/6 equals 15/24. Now notice that all we've had to do is do the top ones together times and the bottom ones together times. And so when you're multiplying, you can simplify first, which we'll get to in a moment, but we end up multiplying the tops together and the bottoms together. Now, by finding our highest common factor of 15 and 24, we can simplify that fraction. We can work out a fraction that's got smaller numbers that has the same value as 15 over 24. And so the highest number that goes into both of those is 3. So I divide them both by 3 and I end up with 5/8. So this is the answer in simplest form. Remember, this 5/8, that equals exactly the same as this fraction up here. It's got the same value, would have the same amount shaded in. Now, being able to simplify this answer here and get 5/8 is all very well, but wouldn't it be nice if we could just get straight to the final answer when we times? And the way we can do that is through what we might call cancelling down or simplifying the fractions first. Now, we're used to simplifying here where we went what goes into 15 and 24, and that was 3. Now, when we're timesing, the number doesn't have to be directly on top of the other one. So 5 and 6, nothing goes into 5 and 6 without remainder, but as long as I'm timesing, I can pick any number on the top and try and compare it to any number on the bottom. And so I can compare this 3 and this 6. Does anything go into 3 and 6? And the answer is yes. A 3 goes into 3 and 6 without remainder. So it goes into 6 twice and it goes into 3 once. So notice that all I've done there is I've just simplified those numbers as if they were part of the one fraction. Just like here, I simplified these numbers into those ones. Here I'm simplifying these two numbers into 1 and 2. And because it's times, as long as one's on the top and one's on the bottom, then that's fine. Even if we had a lot of numbers times together and one was over here on top and the other one was over here on the bottom, it'll be fine. As long as one's on the top, one's on the bottom, and they're all being multiplied. So 5 times 1, that's where we get 5 from. 2 times 4, that's where we get 8. Notice that we've got straight to our final answer, and we'll always be trying to do that simplifying first before we times. Now for division, well, we're not actually going to do any dividing of fractions at all. Anytime we see a divide sign, we're going to flip the second fraction, which is called getting the reciprocal of it, and we're going to change it to a multiply. So if I had 2 over 3 divided by 5/6, that will give me the same answer. If I typed into a calculator, I get the same answer as 2 over 3 times by 6 over 5. And so we don't need to learn how to divide. All we need to do is learn that every divide can become a multiply just by flipping that second fraction upside down. Now also, a lot of the time, if you've got mixed numbers, you have to change them to improper fractions first. So if I have 1 1/3 times 2 3/4, I would change those. I would convert those into improper fractions by doing my 1 times 3 plus 1 gets me 4 over 3, and this one's 2 times 4 is 8, plus 3 gets me 11 over 4, and now I do that multiplication normally. And at the end of your question, when you get the answer, if it's an improper fraction, you often change it back into a mixed number. So if for multiplying and dividing, you have to change before you do anything else. In fact, with dividing, you got to do it before you flip the fraction as well. So the very first thing you do is you get rid of any mixed numbers when you multiply and divide. You don't like them. With addition and subtraction, you actually can do addition and subtraction using the mixed numbers, but if you're not sure how, if you're not familiar with that, then just change them into improper fractions. That's often easier anyway. So let's get into some examples. We're going to evaluate 3 over 5 plus 7 over 15. And so I'll start by writing down the question, and then I need to get these denominators the same, and I do it by multiplying. And I can turn 5 straight into 15. So there's no reason to change the 15, because I can just turn a 5 straight into a 15 by doing times 3. So I times 3 on the top and the bottom, and then underneath that I write my new fraction. Remember, I don't go acrosswards, it's not my final answer. I go downwards, and so I get 9 over 15 plus 7 over 15. Note this one didn't change. This 3 over 5, that's become 9 over 15. And now I add the fractions together. The denominator does not change because the size of the pieces is not changing, only how many pieces we've got. So 9 plus 7, that's 16 over 15. Because this is an improper fraction, 16 is bigger than 15, I'm going to turn it into a mixed number first. Remember, just by going, how many 15s go into 16? That's 1, and there's 1 left over. Just remember, of course, you don't need these green numbers there as well. You can just do that part in your head if you'd like. Now, it's worth noting that sometimes you'll get an answer like this where the fraction can be simplified. Now, unlike with multiplying, there's nothing you can do before the addition to make sure this doesn't happen. So whenever you get your final answer with addition or subtraction, and same with multiplying as well, really, you should always look just to see, can I simplify it? And in this case, 2 goes into 6, it also goes into 8, so I would have to divide them both by 2. If you finish up with an answer that's not the simplest version, you should consider the fact that you've got that wrong, and you should mark it as wrong and then make that correction. Okay, and now for a multiplication. We'll start by writing down the question, and we could just go 4 times 5 and 7 times 12 straight away, but before we do that, I want to see, can I make this easier for myself? Can I find a number on the top that can be paired with a number on the bottom, remember, meaning something that goes into both of them? And so 5 and 12, nothing goes in, sorry, 5 and 7, nothing goes into those. But 4 and 12 works, because 4 goes into 4 and it also goes into 12. So if I cross out the 4 and I put a 1, because 4 only goes into 4 once, and I cross out the 12 and I put a 3, because 4 goes into 12 3 times, that's my new fraction, 1 times 5 and 7 times 3. And so I write my answer underneath, and so it's 5 over 21. Just another quick note here, when you're simplifying, one number doesn't have to go into the other number, just something has to go into both of them. So in this case, for 6 and 15, 3 goes into 6 and also 15. And so I can divide 6 by 3, and that's 2, and I can divide 15 by 3, and that's 5. So it doesn't have to be, oh, 6 doesn't have to go into 15, therefore I can't do anything. Now you've got to see if anything goes into both of those numbers. It doesn't have to be one of the numbers themselves. And in this division here, we have this mixed number problem. So we're going to solve that first. So I'm going to write down the question. And the very first thing I do, I'm not going to flip this fraction or do anything like that yet. I'm just going to get rid of that mixed number. So 1 times 4 plus 1 means I'll have 5 on top and 4 on the bottom. This fraction stays exactly the same, haven't changed that. Now I can answer this using the division. So remember, it's divide. I have to change it to a times and flip these guys upside down. So flip them around. And so now I'm doing 5 over 4 times by 12 over 7. 4 goes into 4 once and 12 3 times, so I can pair them up and cancel them down or simplify them. And so I cross out the 4 and put a 1, cross out the 12, put a 3. Now I do my multiplication. So 5 times 3 is 15, 1 times 7 is 7. And so I write that down, and then finally we can convert it into a mixed number. Now I've just done that over here because I just ran out of space. You should actually keep going down the page the whole way there. So let's give that a shot with some practice questions. Remember to pause the video until you're ready to see the answers. And there are the solutions. With this one here, I had to get that common denominator of 18, and there's plenty of working to show in them all going down the page. Make sure you've got all the relevant working. Now with this first one, I needed the lowest common denominator, and so I thought, what does 6 and 9 go into? And that's 18. That's the lowest number that they both go into without remainder. And so to turn 6 into 18, you had to times by 3, which means I had to times 5 by 3. That's why that's 15 over 18. And here I had to times the 9 by 2 to get to 18, which means I had to times the 2 by 2 as well. So that's why it's 4 over 18. And then I can do my minus. 15 take away 4 is 11. And the 18 doesn't change because that tells me the size of the pieces, and they're not changing. Just how many I've got is changing. So 11 over 18. In the second one, I wrote down the question, and I saw this horrible mixed number here, and I said I'm getting rid of that. So I changed it to an improper fraction, changed it to 20 over 7. And then I started doing my multiplication. But before that, I saw that 20 and 4 can be paired up because 4 goes into 20, and so 4 goes into 4 once, and it goes into 25 times. And so once I've done that, then I could do my multiplication. 5 times 3 is 15, 7 times 1 is 7, and so it was 15 over 7, and then I just made that into a mixed number. And in number C, this is a division, so the first thing I had to do was, after writing down the question, I had to swap these guys around and change it to a times. Now here we can't cancel anything down. Nothing goes into 7 and 5, nothing goes into 2 and 1 except 1, and we don't bother using 1 because if you divide by 1 it doesn't change anything, you get the same number. And so we're just going to have to go straight to timesing. 2 times 7 is 14, 5 times 1 is 5, and then I just change that to a mixed number. So there's some more practice questions here. If you need to have another go at some of them, remember to pause the video. And there's our solutions, again, with all the working that we should have. Hopefully you've got those right. If you're still having trouble, make sure that you ask for some help. And that brings us to the end of the lesson.